surface, circular engraving pattern on an annexized limestone rock. Here I present my research workflow. I'll be skipping this research workflow. We performed the laser engraving pattern for a circular pattern of 1 mm dia, which is shown through this short video, where we had this annexized dimension of the limestone, and the components were utilized as shown here for guide bend, laser nozzle, and coolant pipe, etc. The TI performance evaluation parameter. Performance evaluation parameter for my presented work was selected as the micromorphology features, which could contribute to the formation of thermally influenced zone. The three zones, such as vaporization zone, pulverized debris or melt zone, and the spallation zones, were contributing to the formation of overall thermally influenced zone, where we, for our input process laser processing parameter, we varied laser power, scanning speed, and scan line interval over the 3 SOD values for 3 specimens, and conducted the experiment thrice, 3 replicates. Our main objective was to minimize the width of the thermally influenced zone and minimize the presence of the pulverized debris to have a cleaner engraved pattern. The cleaner engraved pattern could contribute to better slots for sensors and the better slots for sensors integration and electronic components integration to create smart stem-based OS. Here I present my morphologies at 3 SODs. The macro morphologies, where the two common morphologies were striation-based, hash-based patterns or the pulverized debris-based pattern. At different combinations of our input process parameter, we could see the evolutions of the circular ingraves from following the subsequent evaporation of the pulverized debris. In which what we observed is that at SOD values of 6 mm and 7 mm, the best material removals were observed with minimal debris formations or the cleaner ingraves. Next is at 7 mm, where the maximum amount of the circular patterns were observed, cleaner ingraves were observed, and we had more precise formation of the ingraves with minimal TIZ values. We measured the TIZ values as well. At 8 mm, we had defocusing of the lens, and due to the lesser heat flux accumulation at the top surface of the material, we had shallow engravings. And though we do acknowledge that it can be due to the rock heterogeneity as well, anisotropic property or the reflection from the material top surface on the lens. Here I present my measured thermally influenced zone values at the 3 SODs, where we see the lesser peak variability at the SOD values of 7 mm in comparison to the 6 mm. And at 8 mm, we had more variabilities in the peak values of TIZ, with some values crossing 3 mm, but in that it is also attributed to the defocusing of the lens and heat diffusion on the top surface. At 6 mm, we had the maximum SOD, maximum TIZ predominantly below the value of 2.7 mm, and at 7 mm, we had better peak stability of the thermal influence zone. Here further I present my surface morphologies. The common surface morphologies which were observed in across the my 81 combination of parametric observations were raster scan based striations. Further, the pulverized rock debris, where more volume of the debris was in the central zone, and then vaporization of the debris, eventual better removal from the central zone for the cleaner ingrave pattern, and ultimately precise ingrave circular pattern. What the key points which are observed are that at lower power or lower scan speed value, we had in the raster scan mode striation thicker hatchings or spacings, yet mildly pulverized forms of the debris, while at mid value range, such as of 144 watt or the SOD values of 6 mm, comparatively we had more spread out formation of the pulverized debris. When we increased the power value and as well as the SOD values to 7 mm, what we found was that the material removal was better from the central zone, and at mid power range value of 7 mm, as we can see in these images, we had better removal of the material from the center. So, presenting my best combinations of the values, parametric values, where I found better material removal or the cleaner ingrave patterns. Where at this first combination we had the minimum amongst all the 81 experiments, minimum value of thermally influenced zone, while more stable thermally influenced zone values were observed at 144 watt which I have shown in the D and E images. Based on this, my concluding points were like lower values of thermal influence zone and debris-free formation is required for cleaner engravings in rocks, and then standoff distance of 7 mm is better for creating a no debris zone and better thermally influence zone condition. And in my experiment of parametric combinations, the best values were observed for the different parameters are as shown. And based on these key findings, we find laser as feasible for creating stem-based rock destroy applications. But further more extensive researches in terms of simulations are required, or geomechanical investigations required to go into greater depths. These are my references. This work has been carried out under the projects, these two projects. With this, under the supervision of sir, and with this I take my liberty.
Have you checked the scale of this in scale?
Chemical toxicants based.
I understand because see, two things. One is like characteristics of the rock itself.
Yes.
It might be having biotic or antibiotic or something. Its character because you are going to give it to kids.
Yes.
So some microbial action having its natural nature.
Yes.
But you are going to destruct its natural characteristics by laser, and some debris you are observing in different combinations. So have you checked in terms of the biological aspects because you are going to give it to kids? Because in natural rock maybe contamination may not be much attractive, but in after laser cleaning or anything it may be inverse also.
So we have done in the previous my experiments. What we have done is we performed the SEM-EDS and XRD analysis. In that, mainly the mineralogical variations are there; they vaporize. But from the chemical toxicity aspect, I have not performed.
But have you checked that variation is not leading to the inverse characteristics of the rock? I mean, is there any verified report about it? See, I mean, for any industrial application or anywhere else, if you are putting that is, then to some extent, many things can be compromised.
Yes, sir.